Hello student, now today we will discuss the topic numerical solution of equations. Now in numerical analysis there are so many numerical methods are available to find solution of algebraic as well as transcendental equation. Okay, now we sort out the algorithm of the bisection method. Now these are the simple 3 steps for the bisection method which are easy to remember. Now in first step we have to choose 2 real numbers a and b such that f of a and f of b are of opposite sign. So the first task or first step in the bisection method, for a given equation f of x is equal to 0, we have to calculate or we have to choose 2 real numbers a and b. Now the choice of a and b varies over the individual, is it? So choose any 2 real numbers a and b such that f of a into f of b is negative. Now then second step, set xr is equal to a plus b divided by 2 for every r is equal to 0, 1, 2 and so. Now step 3, now calculate f of a and f of xr. If f of a multiplied by f of xr is negative, what it indicates? It indicates the root lies between a and xr. Then in step 2 replace b by xr and calculate again xr. So we go to the next approximation of the root. Now second possibility, if f of a multiplied by f of xr is positive, so what it indicates? It indicates the root of the equation lies between b and the new point xr. So in step second replace a by xr and go to the next approximation to the root of the equation. Now third possibility, if the multiplication of f of a and f of xr is equal to 0, means what? The product of 2 real number is 0 only when one of them is 0. Now by our assumption f of a is non-zero, which is by our assumption which is positive. So the product of these 2 number is 0 means what? Means the value of f of xr is 0. So what it indicate? It indicate xr is the root of the equation. Now in this step terminate the calculation, stop the computation. That means x is equal to xr is the root of the equation. So we have to repeat these 2 steps till the root of the required accuracy is obtained, is it? Now let us see one simple example to find root of the equation using bisection method. Now here x cube minus x minus 1 is equal to 0 is a real valued function whose root to be determined correct to 2 decimal places. That means we have to obtain the numerical root of the given equation correct to 2 decimal places. So you for this equation we use bisection method. So let us use bisection method. Now first step in the bisection method, we have to choose any 2 real number which contains root of the given equation. Now by simple calculation we replace x by 0, 1, 2, 3 and calculate the value of the function. Now if we replace x by 0, that means we calculate value of the function at x is equal to 0, which is minus 1 and which is negative. Now again we calculate value of the function at x is equal to 1, now which is again minus 1, which is again negative. Now then we go to next point, x is equal to 2. So value of the function at x is equal to 2 is 5 and which is positive. So from the first step of the bisection method we have we get 2 real numbers, say a is equal to 1 and b is equal to 2, for which value of the function are of opposite sign. That means f of a is negative and f of b is positive. So what it indicate? It indicate root of the equation lies between 1 and 2. Now we have to find the approximate value of the root which lies between 1 and 2. Now let us go to the second step of the algorithm. So define x naught, which is the mean of the given 2 points, x is equal a equal to 1 and b equal to 2. So 1 plus 2 divided by 2, we get the first approximation to the numerical value of the root of the equation f of x is equal to 0. Now once we get the first approximation, we have to check value of the function at a given point x naught. Now calculate value of the function at x naught, that means value of the function at 1.5. Now which is 8 divided by 7 and the sign of the number is positive, that means value of the function at x naught is positive. So what it indicate? It indicate the root lies between 1 and 1.5, because value of the function at 1 is positive and value of the function at 1.5 is positive. So root lies between these 2 points. So we calculate next approximation x1, which is 1 plus 1.5 divided by 2 and which is 1.25. So this is the second approximation to the numerical value of the root of the equation x cube minus x minus 1 is equal to 0. Now then we calculate value of the function at x1. So by numerical calculation, f of x1, that means f of 1.5, which is minus 19 divided by 24. That means the value, that means sign of the value f of x1 is negative. So what it indicate? It indicate root lies between 1.25 and 1.5. 1.25 and 1.5. Then again we bisect the interval 1.25 to 1.5 into 2 equal subintervals. That means we define third approximation x3 to the root of the equation. Now x2 is equal to 1.25 plus 1.5 divided by 2. After calculation we get 1.375, and this is the third approximation to the root of the equation x cube minus x minus 1 is equal to 0. Now we have to continue this process till we get the root of the equation correct to 2 decimal digit. That means we have to continue that process till we get these 2 digits repeat. Okay, now again we check value of the function at x2, which is 115 divided by 512, whose sign is positive. So what it implies? It implies the root of the equation lies between 1.25 and 1.375. Now again we calculate the next approximation to the root of the equation, which is x3, which is 1.25 plus 1.375 divided by 2, which is after evaluation we get the value 1.3125, which is the fourth approximation to the root of the given equation. Now again we calculate the sign of the function at x3. Now continue that process till we get the required root correct to 2 decimal places. Now we calculate value of the function at x3, which is minus 211 divided by 4096, whose sign is negative. So what it indicate? It indicate the root of the equation lies between 1.3125 and 1.375. Now using this condition, we go to the next approximation, namely x4, whose value is 1.34375. Now x4 is the fifth approximation to the root of the equation. Now again find the sign of the function at x4. So we calculate value of the function at x4, which is positive. So what it indicate? It indicate root of the equation lies between 1.3125 and 1.34375. Now again using this condition, we calculate the next approximation to the root of the equation, which is x5. So x5 is 1.328125. This is the sixth approximation to the numerical root of the equation. Now again we calculate value of the function at x is equal to 5. Is that clear? Okay. So we calculate the value of the function at x is equal to 5, which is again positive. So what it indicate? It indicate the root, new root lies between 1.3, that means x5 and x3. So root lies between x3 and x5, because the value of the function at x3 is negative and the value of the function at x5 is positive. So the new approximation to the root of the equation, which is given by x6, that means seventh approximation to the numerical root of the equation, which is 1.30312. Now let us see the value of x5. x5 is 1.32. Now after decimal point the digits are 32 and the value of x6 after decimal point it is again 32. So what it indicate? The value repeated 2 times, that means x5 and x6 are correct to 2 decimal places. So which is the correct root of the given equation correct to 2 decimal places, and therefore the required value of the numerical root of the function is 1.3203125, which is correct to 2 decimal places. Is that clear? That means the bisection method is one of the fundamental method to find root of the any equation. It may be algebraic equation or transcendental equation. Now in next lecture we will discuss the method of false position method, which can be used to find root of the equation. Okay, thank you.